So next question is from an inclined plane a particle is thrown in a direction normal to the surface. Find the ratio of successive range of the particle on the inclined plane. Consider all collisions as elastic collisions. In this case, let us first of all draw the diagram. Inclined plane is given. Let us suppose the angle of inclined is given as theta, and the particle is projected at a velocity which is normal to the plane. Suppose this particle is projected from position A and it falls at position B. Now what is going to happen? We can find out G will be acting in downward direction, so there will be two components of G. This component will be called as G sine of theta, and this component angle theta, this will be called as G cos of theta. So let's divide this. This is point A. It is projected from point A with a vertical velocity u, and it strikes the plane first time at position B. So let us discuss it first two cases. First, let's divide it into the vertical motion. So vertically, we can say that initial velocity u of y is equal to u distance is 0 in y direction, acceleration is given by minus g cos of theta, and let us suppose that time of flight is given by t1. One important thing is that as there is projection velocity only in vertical, so we can also say that u of x is equal to 0 and u of y will be equal to u. So we are going to use formula s is equal to ut plus half gt square, rather at square. So in y direction, so s of y is 0, so we can put it as 0 is equal to u of y is given as u ut minus half g cos of theta, time is t1, so we can write this as t1 square. So from this we are going to get two values. If we take t1 common from both, we get either t1 is equal to 0, which is not possible. So second condition will be u minus 1 by 2 g cos of theta multiplied by t1 is equal to 0. From here we can find out t1, which will be equal to 2u divided by g cos of theta. For the same from A to B, now we are going to discuss horizontal motion. U of x is 0, acceleration in x direction is given by g sine of theta, and let us suppose the distance traveled in x direction is given as a range. So at first we can go to call it r1, and time is given as t1. So again we are going to use same formula. S of x is equal to uxt plus half axt. So is the t1, so we write t1 and this is square. So u of x is 0, so we get r1 is equal to half a of x is g sin theta multiplied by t1. t1 is 2u g cos of theta. G cancel out with g, 2 goes with 2, so we get r1 is equal to, we can get 1 by 2 g sin theta. I missed the square of that, so we can write this as 2u g cos of theta and its whole square. So this can be further solved as r1 is equal to 1/2 g sin theta multiplied by 4u square divided by g square cos square theta. This goes by 2, g cancel out square, so we get r1 is equal to 2u square sin theta divided by g cos square theta. So this is the range from A to B. So now we come at point B, so we write at B we are going to find, now the velocity is going to have two components at point B. One will be the vertical component and another one will be the horizontal component. So we are going to find both components at point B. So let us first of all find out what will be the horizontal velocity. So we already know that u of x is equal to 0, a of x is equal to g sin of theta, and time period t is given by t1. So if you find out horizontal velocity, v of x is equal to u of x plus a of x multiplied by t1. So u of x is 0, a of x is given by g sin theta, and t1 we already know, t1 is given by 2u g cos of theta. So g cancel out with g, we get v of x is equal to 2u tangent of theta. Now we find out the vertical velocity. So in vertical direction, we know that v of y is equal to u, a of y is minus g cos of theta, and t is equal to time t1. So again we are going to use same formula. V of y is equal to u of y plus a of y t1. So u of y is given as u minus g cos theta, and t1 is given by 2u g cos theta. G and cos theta cancels out, so this comes as u minus 2u. So we can say that v of y is equal to minus u. Okay, now we go for the, we draw the diagram again. Now the object is already at B point, sorry, particle is already at B point, so it is going to bounce like this, and let's suppose it touches point C. So here it has two components, one is horizontal velocity component and another one is vertical component. So, and this is previous A point. So again we divide into two parts. First is the horizontal, so we write horizontal so we have u of x, we already found out, that is equal to 2u tangent of theta. A of x will be equal to g sine of theta, and let us suppose the range in x direction, this is the second one, so we call it r2, and the time t will be equal to t1. So again we use the same formula, s of x is equal to u of x t1 plus half a of x t1 square. So you put the values, u of x is given by 2u tan theta, this is 2u tan theta, t1 we already found out, that is 2u g cos theta plus half g sin theta, and we have multiply it by square of t1, g cos theta whole square. So we can write this as 4. If we write 10 as sin theta over cos theta, so this will be coming as 4 u square sin theta divided by cos square theta plus 1/2 g sin theta multiplied by 4 u square g square cos square theta. G cancel out with square, 2 goes with this 2, so this is left as 4 u square sin theta divided by, sorry I missed the g cos square theta plus 2u square g cos square theta. And we already found out that r1 is given as 2u square cos square theta, so we can write this as 2r1 plus r1. So we can say that r2 is equal to 3r1. Now once again at point C we are going to find out what will be the horizontal velocity as well as vertical velocity. So at C, first of all we find out what is the horizontal velocity. So we already know that initial velocity u of x is given as 2u tan theta, and a of x is given as g sine of theta, and t is equal to t1. So we use the formula vx is equal to ux plus a multiplied by t1. So if you substitute the value of ux, that is 2 u tan theta plus a is given by sin theta, and t1 we already know is given as 2u g cos theta. So g goes with g, so this is left with as 2u, this is tan theta plus 2u tan theta, so we get Vx is equal to 4u tan theta. Now we find out what will be the vertical velocity. So we know that u of y is given as minus u, and a of y is equal to minus g cos of theta, and time t is equal to t1. So we put value v of y is equal to u of y plus a of y t1. So this is minus u minus g cos theta multiplied by t1, and t1 is given as 2u g cos theta. So they cancel out this, so we are left with minus u minus 2u, so we can say that v of y is equal to minus 3u. Now we draw the diagram again, and in this case now the projectile is already at point C. Let us suppose it reaches point D. So this will be point B and this will be point A, which I have already solved. So at point C, again it is going to have two components, horizontal as well as vertical. So let us go for the horizontal first of all. So we get horizontal we write u of x, we already know, is given as 4u tan of theta. A of x is equal to g sin theta, and let us suppose the distance in x direction is given as r3, that is range 3, and t is equal to t1. So we are going to use formula s of x is equal to ux t plus 1/2 g a t1 square. This is t1. So sx is given as r3, ux is given as 4u tan theta multiplied by t1. T1 we already know is given as 2u g cos theta plus 1/2 acceleration is given by g sin theta multiplied by t1 square. It means 2u g cos theta square. So we left with 8 u square. Once again we can write this as sin theta upon cos theta. So we get u square sin theta divided by g cos square theta plus half multiplied by g sin theta multiplied by 4 u square g square cos square theta. Square cancel out with g, this comes 2, so we are left with 8 u square sin theta divided by G cos square theta plus this will be 2u square divided by sin theta divided by G cos square theta. And we know that this is nothing but our R1. So we can write this as 4R1 plus R1. So we can say that R3 is equal to 5 times R1. So R3 is equal to 5 times R1. 2u square sin theta divided by GR square, G cos square is R1. So we can write this as 4 times R1. So we got both the R3 is equal to 5 times R1 and R2 is 3 times R1. So we can write ratio of R1 is to R2 is to R3 will be equal to 1 raised to 3 raised to 5. So this is the final answer. Thank you.